The technical advances of recent years have not stopped at the field of astronomy. Gigantic discoveries, such as the first photo of a black hole, show that there are still numerous unexplored objects and phenomena in our universe. According to extrapolations by astrophysicists, there are probably as many as 100 billion galaxies in space, and an equally large number of planets in the Milky Way alone, whose existence we have not yet learned of. The section of the universe which humans can see resembles a tiny puzzle piece, which has been put together by researchers for centuries, piece by piece. Not even the solar system known to us has been completely explored, as can be seen from the discovery of the possible dwarf planet far out only 2 years ago, or the discussion about a gas in the atmosphere of Venus that could indicate life. For several years, researchers have also speculated about the possibility of another planet in our solar system. Since Pluto's planetary status was revoked, 8 more have been counted among them. The latest research results from California should give astronomy enthusiasts cause for excitement. There is actually mathematical proof for the 9th planet in our solar system. If you like our videos, feel free to support us with a thumbs up, subscribe to Simply Space, and be excited about the videos that will be waiting for you in the future. In the history of astronomy, one planet has been predicted before it was finally proven through observation with a telescope. This was the blue gas giant Neptune, whose position was predicted by mathematical calculations in September 1846 by the Frenchman Urbain Le Verrier, based on orbital perturbations observed with Uranus. Already hundreds of years before, the planet was observed, among others, by Galileo, and not recognized but mistaken for a star. It fell again into oblivion. Only by a letter from Le Verrier to the German astronomer Johann Gottfried Galle did the latter search for the predicted object and confirm Le Verrier's calculations. The existence of Neptune was confirmed. In modern times, there have also been speculations for some time that there could be an unknown 9th planet in our solar system, which has been christened with the research title Planet X. Before the discovery of Pluto, there were already, in the 19th century, first speculations that an object must exist beyond Neptune. In the meantime, there was even talk about up to 3 other planets. For some time, these opinions remained without proof. The 2 scientists, Konstantin Batygin and Michael E. Brown from the Technical University of California, a top university in the field of engineering and natural sciences, have now finally presented mathematical evidence that the said 9th planet must exist. Planet X is a hypothetical planet that orbits far beyond the dwarf planet Pluto, which is why it used to be called trans-Pluto. The 2 researchers assume that the object must have a mass of 10 Earths and has an extremely long orbit around the Sun. While our Earth orbits the Sun in 365 days, Planet X would need at least 10,000, and in extreme cases, up to 20,000 Earth years for a single orbit around our central star. For comparison, the planet Neptune, which is the farthest from the Sun, takes about 165 Earth years to complete an orbit, while Mercury, for example, does it in a marathon-like 88 days. The 2 astrophysicists from California got on the path to test this hypothesis via the work of colleagues, who first declared the idea of a planetary object beyond Neptune plausible. Ironically, by their own admission, the researchers initially worked on a model that was intended to disprove, not prove, the existence of Planet X. In the end, the calculations favored the idea of a planetary object beyond Neptune. Afterwards, however, the calculations spoke for nothing else than an object of this size, which is capable of twisting the orbit of said objects by a full 90 degrees, and thus provides for their unusual shape. In an article on January 20, 2016, in the influential Astronomical Journal, Brown and Batygin first hypothesized that Planet X must have entered the Kuiper Belt region about 3 million years ago, and that this could have been caused by the gravity of the gas giant Jupiter. The Kuiper Belt is a ring-shaped region outside the orbits of Neptune, which is located between 39 and 48 times the distance to the Earth. This means the average distance between the Sun and the Earth, which is about 149,597,870,700 meters. The best-known object in the Kuiper Belt which lies at the outer edge of our solar system, is Pluto. The icy and dark region is known for a variety of interesting astronomical objects. For example, numerous comets are known to originate from the Kuiper Belt. However, due to the long distance to Earth and the very weak reflection of sunlight, objects in this region of the universe are difficult to observe. This is also the reason why Planet X has so far remained hidden from the human eye. Recent discoveries from the Kuiper Belt include a number of dwarf planets similar in size to Pluto, eventually costing it planetary status at the infamous International Astronomical Union Conference. So how can the existence of Planet X be explained? One should recall again the history of Neptune. This was finally predicted by the orbit disturbances and discovered. But also Neptune itself is affected by distortions of its orbit, which cannot be explained by Pluto alone. After all, the dwarf planet ultimately has too small a mass to affect Neptune's orbit on this scale. But Neptune is not the only planet affected by these perturbations. Beyond Pluto, a variety of objects also orbit the Sun with very unusual orbits that must be explained by the gravity of another, as yet unknown object. This is where Planet X comes in. Its hypothetical size and mass provide a plausible explanation for the discrepancies in the Kuiper Belt and beyond. The orbits of a number of smaller objects are thought to be explained by the new planet. The orbits of these objects tend to form agglomerations or clusters. These can only be explained by the gravity of a larger object. These include objects like Sedna, which have highly elliptical orbits. Brown and Badigeon's calculations suggest that Planet X is an ice giant with a suspected surface temperature of minus 226 degrees Celsius. It should also have an orbit in the shape of a major, semi-major axis. The evidence for Planet X is still based on mathematical model calculations, which are almost certainly correct, but do not yet give us a concrete idea of the appearance of this unknown Big Brother. However, this is expected to change soon. The research team has already announced that the technical possibilities are now sufficient to the extent that the best telescopes in the world will be able to detect the ninth planet and take a first photo. For example, TESS, the telescope developed by NASA for exoplanets, is capable of doing just this. A new technique known as shift stacking will be used for this purpose. In shift stacking, possible orbits that an object can take are first defined. In the following step, a specific point in the sky is observed by a space telescope for a period of several weeks and matched for scattered light from various objects. To do this, hundreds of images of the section of sky are taken and then stacked, allowing the amount of light from the potential object to be calculated. The problem with unknown objects is that they reflect very weakly the sunlight and are therefore extremely difficult to identify by pure observation. In the further course, the possible path of the object is verified by further observations. This method has proven extremely useful in astronomical research to detect objects in Neptune's sphere of influence. In a recent paper by Greg Laughlin and Melina Rice of Yale University, images from NASA's TESS exoplanet telescope were used to capture signals from several trans-Neptunian objects. Now, the research world is hoping to finally get a snapshot of the still invisible Earth sibling. Although there is no unanimity in the research world, and there are critics of the notion of Planet X, Brown and Badigeon are certain that it must exist. Badigeon himself estimates the probability of its existence at 99.9%. Now it's up to the astronomers to take the first photo and, thereafter, take credit. Also, a name for the new planet is still pending. It is a good tradition to name previous planets after gods from Roman mythology. But no matter what it will be called in the end, the hunt has already begun. The astronomical search for Planet X is progressing, and with it, the discussions about what it might look like and what properties it might have. We're particularly interested in the opinion of our viewers. What do you think of Planet X? Do you find the presented evidence plausible, or do you doubt it? What do you think Planet X could look like? And do you think that besides this one, there are other undiscovered planets in our solar system that have remained hidden until now? Feel free to write your ideas in the comments section.